Welcome to the Bentley Offshore Special Interest Group. Today we're going to be talking about creating stiffened joints using pre-seed and joint mesher. Today we're going to be talking specifically about defining plate surfaces using pre-seed, exporting a joint mesh input file once we've created those plate surfaces, and then mesh the joint automatically using pre-seed. So if you were in the previous special interest group video, we had a presentation where we talked a little bit about using the joint mesher, and that was all text-based and data gen. Now we've included a way to define the plate surfaces using a GUI, which should be a lot easier for a lot of people to work with. And so that's what we're going to be talking about. I'll highlight a little bit of the differences between the text input file and the GUI as we get to it, but for the most part it's going to be pretty much the same in a lot of ways. So let's go ahead and open up the input file, a SACS input file. It is a basic model file, just a few beams. We've got some beams here. We've got a tubular cord and vertical tubular braces. The connection is a bit odd in that the bottom flange is flush for the primary and secondary girder, whereas usually the top flange is flush. But that really shouldn't matter for this example. We're just trying to get an idea of the basic information about, what something like this, what a joint mesh would look like for this. Okay, so first thing we're going to do is go to the Joint tab and select the Joint Mesher button in the Connection group. Okay, so when we select that, a dialog pops up. It's going to show us the joint name and option to input a joint mesh input file. We're going to be doing this from scratch, so I'm not going to put a joint mesh input file in, but I'm going to select the joint here, and that will fill it in the joint mesher dialog. Okay, so when I click OK, a new window will pop up, and this is the mesh tool boundary window. Okay, so let's see here we have the mesh boundary tools. And there's a few things that we can see now. We have the mesh boundary elements window on the side, and it's got a tree view. You can see it all kind of originates from the joint. We have members, member lines, and then this is going to be where our plate surfaces and planes and everything are located. On the right hand side you can see the mesh joint properties. These are dependent upon the mesh joint tree, and so these are going to correspond to kind of whatever you're selecting on the tree view over on the left hand side. So you can see here for the mesh joint properties, all of these are basically the joint mesh options on the joint mesh option line in the joint mesh input file. And here you can see on the member properties we got a few options like mesh length and mesh type. And this is actually how the mesh will be generated for that particular element. Okay, so that's the meshed member properties. And the last thing that we're going to talk about is the instructor view. So you can see down at the bottom there is an instructor view. It's going to be a kind of a helper for basic things. So here, for instance, all of the options, it's context sensitive to the options that you have, and it's going to show you basic operations. So when you don't have anything selected, though, it's going to show you a general operation for the Joint Mesh GUI. And this is a good reference if you don't know what you're supposed to be doing, so kind of guide you through the process. Right, so here we can see the first thing we need to do is add a plane. Okay, and once we add that plane using the Add Plane button, we can then add a plate surface, which will allow us to actually put the plate on, and we can define after we define the plate surface, save the mesh input file. Okay, and then we can mesh the joint using the mesh joint button. And then we also have some modifier keys. You can right-click on elements in the tree view to do things like add hard points, hard lines, and hard planes, or modify existing lines, copy or delete them. So you can see over here, if I right-click, I can add a hard point or something like that. So if I go to the active structure, you can see that, it's going to be adding hard points, hard lines, hard planes that will create boundaries where plates cannot cross. It's the easiest way to think about it in my mind, is that the hard line essentially is going to add a boundary for a particular element where the plate surface won't cross. And this is useful if you're going to do things like delete elements after you create the mesh, if you're planning on modifying it after doing the mesh. It's also going to be used for applications like extracting SCFs. That's really the main application for this. We want to be able to use automatic SCFs extraction, which the developers are still working on, but when we get that, those will be used for that application. Okay, so now we can go ahead and add a plane in at the top flange. It's not going to connect with the bottom flange here, just the top flange. And then we're also going to want to put in a plane at the bottom flange and an additional plane for the secondary girder. And do ring stiffeners for all those. And we might do a vertical stiffener between the brace and the girder if we have time. So here we're going to go back to the mesh tool. We're going to just mesh the joint without using any joint mesh input file. It's going to ask to save one, but we haven't really put any information in, so it's just going to be the default mesh. And this is a useful way to look at the model and see kind of what the mesh is going to look like in the default setting. And you can get a few good pieces of information out of it, like, for instance, maybe if we want to extend the meshable length of a particular member, or increase the mesh intensity, something like that. We can also grab the elevations from particular elements, so we don't have to do too much math. We can just grab the vertical elevation here for our first plane definition. So we can just make a note. It's 24.188. We can probably just use 24.2 for this example. But instead of having to get that from the z-coordinate and then get the depth of the beam and the thickness of the plate, it's much easier just to do it this way. Okay, and we also get a output file that shows us all of the information about the mesh and if there were any warnings or errors. Okay, so here we're going to add a plane, and you can see the plane shows up in our tree view down there, and we'll have a description which we can rename. This can be whatever you like. I'm going to leave it at plane 01. We have different plane location types. I'm going to use global XY because this is in the horizontal plane. Plane offset, this is where we put the z coordinate. Okay, so I'm going to put in, what was it again? I'm just going to open that joint mesh file up again because I've forgotten the value. So let's just see here. It's 24.2. Okay, so Let's go back to the input file so we can enter that in 24.2. Okay, and then we're going to hit enter to apply. Alright, so you can see now we see the outline of the beam, the tubular, at that plane location. So these are kind of used as construction lines. You can see right here, that's going to be the outline of the tubular, and then we have the primary girders. Those can be used as construction lines for drawing our plate surface definitions. Okay, and you can see that the secondary girder is not going to show up because it's not on that elevation. Okay, so here we can see, that's the circle for the tubular, and then the two primary girders there. All right, so you can see we're going to do an arc here, basically to trace that tubular for an arc. We're going to do another arc outside portion of the ring, and then we're going to have a transition piece that connects the girder to the ring. Okay, and so you can see I'm selecting lines here. We can add a plate surface here. That's the next step. And on the plate surface, we're going to have to define a thickness for the plate. And we can also rename the plate. So instead of being bound 1, I think we'll name this something along the lines of top flange 1. Yeah, top flange 1. We can change the mesh type if we'd like. We can leave it at triangular for this example, and then we'll put in a thickness. I'm going to use 2.5. In my preparation, I looked at the flange thickness, and I think the flange is 2, so 2.5 should be appropriate. Now you'll note if I modify something and don't apply it, so sorry, if we look at these, we're going to have the plate properties, and these are just going to be applied to any plate that's generated for that plate surface. And then we also have plate offsets. So plate offsets, those are going to be if you want to move the plate surface relative to the plane, but in this case we've already put the plane where we want, so there's no real reason to do any plate offsets. We're going to leave that at the default values as well. Okay. So here, I just want to make a point out, if you modify the thickness here and you don't apply it, it'll show up as a bolded value. Okay. I mean, it hasn't been applied yet. So you want to enter in 2.5 and hit enter, or click the apply button at the bottom there to make sure that it's actually applied. Alright. So we're going to do two plate surfaces. We're going to do one on the top and one on the bottom. The reason for this, I'm not going to explain it right now. It's going to be a little bit clearer when I actually have some plate surfaces drawn. So I'm just going to do the top half right now. So we're going to start using the draw tool. So we've already gone through all of the views and everything. So now we can get to the draw tools and modified tools. So here we have the arc line. We're just going to draw an arc. We have arc transition, line tool, lines tool, and these are all of our draw tools that we have. We also have some modify lines. So we have the split at intersect, trim, extend, and meet two lines. But the first thing we want to do is create an arc. So I'm going to select that. And if you can see down at the bottom right, the instructor view shows how you basically do an arc definition. So I'm going to click the center, then I'm going to click the first point, and then I'm going to click the end point. And here you can see the tool operation, what to do. And also at the bottom there you can see that there's some hotkeys which you can press to modify your input. So we'll get the first arc drawn here. So I'm going to click that. I'm going to click the center. You can see it's going to snap to a few different lines. Here it's, you can snap to the endpoints of lines. We also have a grid, so if you zoom in a little bit, you can see the grid pop up, and the cursor will actually snap to those points too. You can modify the grid spacing if you'd like. I'm going to leave it at 0.25 though. So here we're going to click the center. We're going to click the end of the tubular on the right hand side, and then we'll click the left hand side and draw that first arc there. Okay. Once you have that drawn, you can see on the, if you have that arc selected, you can see the properties of the arc, and these values you can view. You can also modify them if you want to change something. This looks pretty good though, so I'm going to leave all of these values. Okay, so one thing we can do is we can copy and paste this same arc to the same plate surface. Now we have two arcs there, and I'm just going to modify the radius here to 3.5, and you can see that it'll actually set the coordinates of the endpoints to match that radius. Okay, so you just have to modify one value and apply it. And so that's a convenient way if you have a similar value, but you just need to modify one thing, then you can just go in and do that. Okay, so let's see. Everything looks pretty good here. Now I'm going to add the lines to define the transition piece. And I think I'm going to put it, actually I think what I'm going to do is put this at 3, and then I'm going to put the end of the transition piece at 3.5. I think that's what I did in my example I did before. So let's see. So we're going to create a line for the flange here, and you can see down at the bottom right it's going to show you the coordinates that you're going to be selecting. So this give you a little bit of a good idea. I'm going to go look at that and see 3.5. Create another line, center line, and then create a line to connect those two pieces. Okay, and then I'm just going to do the same thing on the other side. I'm going to create a line, another line, and then connect those two pieces. Okay, and here are all the basic lines that we've defined for this ring stiffener. Now you can see that there are some lines that are intersecting. It's not really some lines that shouldn't be there, so we're going to use the modify tools to clean that up a little bit. So the first thing we're going to use is the trim extend tool. Again, you can look at the instructor to see how to use that. But essentially what we're going to do is click the first line to be trimmed, then click the second line, and it will trim it to that point. Make sure that you're clicking the portion of the line that you want to keep when you click that. Uh-oh, I think I clicked the wrong line there, so I'm going to undo a bit, and then click the line I want to keep, and then click the line to trim. That's not working. Let's see, maybe must have messed something up here. And by the way, I'll just point out that I may be making some, oh that worked. I may be making some mistakes along the way, so bear with me. It's a live demonstration, so these things happen sometimes. Okay, so let's see, what else do I need to clip here? Let's see, I think actually I've made a mistake. I want that inside tubular to go all the way down to the center line. So we're going to redo this. We're going to use that portion to trim, we're going to trim that line there. So let's see, we trim that off. We're going to trim this part off with the inner arc. And then let's see, what else do we need to trim? We need to trim that piece right there. So we're going to click the side we want to keep, trim that, and we're going to trim the outer arc. So we're going to trim that like that. Okay, and then we just need to repeat this process on the other side here. So I'm gonna, let's see, click that line, trim this outer transition piece. There we go. We need to trim those arcs. There. Okay. So that looks pretty good. There is one more thing that we want to do, though, is we want to create an arc transition between the outer ring and the flange piece. So I'm going to use the arc transition. The way that you use this is you click the first line, the second line, and then the side where you want the arc to be placed, because if you it could go either way, right? So we're going to click the arc, we're going to click the flange line, and then click the side that we want it on, and I'm going to put in a 1/2 foot radius. And you can see this selection is to split the lines. This is useful if you want to delete the lines after you create the arc transition, which we want. So here you can see the arc transition has been created, and we're going to select some of these additional pieces just to delete them. You can delete using the delete key on your computer. And we'll do the same thing on the other side, create an arc transition, and again delete those additional pieces that we don't need. Okay, so that looks pretty good. That's the top piece has been completed, and we are ready to start with the bottom piece now. Okay, so I'm going to copy that plate surface. Actually, no, we don't want to copy the plate surface. We want to just create a new plate surface on the same plane. So we'll do that now. Make it 2.5 inches, and then I'm going to call this top flange 2. Okay. And we're just going to do the same thing that we did for the top one. We're going to try doing some slightly different things, so just to show different ways to do these things. So here I'm going to select this line. Remember I had said this could be used as a construction line. You can actually duplicate it, and it'll add that line to the active plate surface. And I'm going to do the same thing for the other line here. We can do it for these two flange lines as well. And then I'm going to do the same thing for the inside tubular. Okay, so there we go. That's easier. We've already done quite a bit of the lines that we already need. Oh, I wanted to create that one, but outside arc, but I don't want to do that. So let's go back. I'll just duplicate it here on the tree view. Copy and paste it. There. And we can increase the radius to 3. Alright, that looks pretty good. So let's see, all we need to do is add the outside lines for the transition piece there. Okay. And now we can start cleaning it up. Okay, so let's see. I'm going to try and trim this arc. It might be a bit difficult because it's continuous, so it might get confused. So maybe I need to use the split tool. No, that's not going to work. Maybe the easier way is just to modify the start and ending point. So I can go in here and just modify the end location to be negative 1.8. There, that should be good. So we have that piece, and then we have this piece. Okay, good. And I can do the same thing for the outside arc here. So let's select that line and make this negative. Okay, great. So now we have that piece and this piece. Great. Okay, so now we just need to trim some of the other lines. Here we'll trim it by the outer flange piece there. Oh, click the wrong line. It will tell you if it's not appropriate or not applicable. So let's do that. Did it again, in case you didn't see it the first time. Alright, let's see. So I need to trim this line by that. There we go. And the same thing over here. Great. And then we need to trim the line. Okay, so the arc is out to the outer side of that. And then we need to keep that piece, nothing else. Okay. Same thing. Alright. Oh, good. That looks pretty good. We, only thing left to do here is we need to add the arc transitions. So I'll talk a little bit about the top surface versus the top plate surface versus the bottom plate surface. You basically want to make sure that you have a continuous single closed boundary for the entire plate surface, because the mesher will have problems if you have multiple boundaries. It can't determine where the plate mesh is actually supposed to be. So that's why we've created two plate surfaces, the top with the line going through the middle there. The top surface, you can trace a line all the way along it and back up at the starting position. Okay, so if we didn't have that line, then you would have two lines. You have the internal ring and then the external ring, and it would be difficult for SACS to figure out where the mesh should be. I don't know if that's ever going to change. It may, and I will let people know if that happens, but currently this is the best practice to do multiple plate surfaces in the same plane with just do a single continuous closed boundary. Okay, so we need to do the arc transition here before we finish this ring plate. Okay, so click that, and then just delete the additional pieces. Okay, there we go, and good. Alright, so I'm going to save that, and we can also save as if you want, just overwrite that. Remember when we did the original mesh, it created joint mesh input file, so save it over that, and then we'll mesh the joint just to see what we've got. Okay, so here you can see the ring has been placed in there. I'm going to display the plane at XY plane, just a little bit easier to see. And here you can see the transition piece here, and then we have that our arc transition and the external ring, and you can see the internal ring in here too. Okay, and it looks pretty good. We may want to increase the mesh intensity or decrease the element size to because that arc transition looks a little flat there. Might want that to be a little bit smaller mesh size to get a better representation of that. But generally this is pretty good. So let's see. We'll go back, and I'm going to go back to the model file, and oh, here you can see we've got a bit more information in our mesh input file since we actually had a bit more information in there. If we scroll down, you can see here are the meshed elements and all the mesh members, I should say, and then the mesh plate boundary surfaces here that we named. Okay, so that's just some information there. Okay, so now I think we are ready to add a plate surface to the bottom flange. Okay, so we can just copy and paste this. And you can see here we have the top flange and then we have the bottom flange, and essentially all we really want to do is add the transition pieces for the secondary girders. Okay, so it's going to be much simpler than doing this from scratch and just to copy and paste it. So what we can do, we can't copy the plane, we have to define another plane, but we can copy the plate surfaces. Okay, so what we're going to need to do is create a new plane here, And we're going to put in minus 24.2 to be the bottom flange. And you can see here we have the primary girders and secondary girders displayed. Gives us a good indication we're in the right spot. And then we can copy and paste that plate surface into the bottom. You can see it just pop up right there. I'll do the same thing for the other plate surface. Okay, so copy and paste. And here we go. So now we can start modifying these. The only thing that's not copied over is the plate surface label. Everything else will be copied over, so we can rename this to something we want, like bottom flange 1. And then we can do the same thing here, bottom flange 2. Alright. So now we'll go in here, we'll start modifying this to add the transition pieces for the secondary girders. Okay, so we want to make sure we're selecting the right plate surface here. So I'm going to duplicate these lines here and do the same thing down. No, we'll do that later. Let's see, we'll do the transition piece here. I'll add that line, and then we'll just trim. Oh, looks like I added it to the wrong plate surface. So if you'd ever do that, you can just drag and drop lines in one tree view to the other. So here we'll just drag and drop it to the other plate surface. There we go. And just do that for each line there. Okay. So now if I select that plate surface, it should show. There we go. All of those lines are on the right plate surface boundary there. Okay. So I'm gonna trim these lines just to make that transition piece. Let's see. Here we go. It's looking pretty good, and we can just put in the arc transition here. And do the same thing on the other side. Great. Okay. And then we can do the same thing for the bottom flange. And we don't need that middle line. Uh-oh, I must have, looks like I didn't select the correct plate surface when I was creating those trim lines. So again, I'm trying to go a little fast here to make sure we have enough time. So I must have just made a mistake there. We'll just drag and drop those lines up there and it should be fine. Make sure we do that. Get all of those lines. Then we can select the plate surface to make sure we have all the right ones selected. Okay, that's looking good. Alright, so we need to add that one last line at the end there. And do the same trim commands. And then do the arc transitions. And then we can just delete the extra pieces. There we go. Alright, so now we've created our bottom flange mesh. We can go ahead and mesh it again. Let's see what we've got. Let's see, we can display the plane at the bottom flange now. And there we go. So you can see now we've got the primary girders and the secondary girders displaying with all the transition pieces and the arc transitions and everything. And again, we might want to increase the mesh intensity, decrease the element size, but for our purposes, this should be fine. Alright, so now we've done the same plane definition, so I want to do something a little bit different here. I'm going to add in a vertical stiffener between the tubular brace and the girder. So we're going to do that. We're going to add a new plane, but use a different way to define it. Okay, so we're going to add it between those members instead of defining it on the, the XZ plane. Okay, so let's see, we can look at the active structure while we do this, which is a little bit more useful than looking at the, mesh tool. So go back to the active structure, and we can pick out between two members. Okay, so we're going to do it between 2000, 2002, and 2000 and 3002. So I'll select that. 2000, 2002, and 2000, 3002. There we go. And we'll apply that. And now you can see here we've got the vertical braces outlined, the tubular cord, and the girders there. Okay. Yeah, so this should correspond. You can see pretty clearly what's going on there. Alright. So I'm going to add a plate surface here, and let's just make this an inch. Okay. And I'm going to try a few different things here. So essentially we want to do a triangular stiffener here. So let's see, we're gonna play around with some of these different modify options. So I'm going to duplicate this line for the bottom of the vertical brace, and then we'll just add in a vertical line here, and let's try meeting the two lines. Oops, I selected the member line. That's not what I should do. That may have been why I was having other issues. I'm going to turn off the member outline there on the visible layers, so it's a little bit easier to see what we're working with here. So let's do the meet two lines. Oh, I may have, that's not the way I wanted to do that. So let me select that. No, I think it might be because there's more on the other side. So let's do it a different way. Let's do the trim extend. It's going to be a little bit better. Meet two lines, just if two lines don't intersect, it will extend both of them to meet it. I wasn't really using it appropriately there, but let's see. Now we can split intersect. Oh, that's not how it was supposed to work. Let's do that again. So we're gonna split intersect. This one we're going to select the two lines, and it's going to split that vertical line into two different lines now. So we can see here we've got the bottom one and the top one, and then we can just delete the top vertical line there, so we don't have that anymore. Okay, and we can turn this back on, and let's see, we need to add a couple more lines here. I'm going to trim that. Uh-oh, that didn't work quite right. There we go. Must have selected the wrong side of it there. I'm going to duplicate the top flange of the girder, and then we'll just add a vertical line here, just kind of randomly. And I will do the meet two on, see if it works for this one here. There we go. So that extended it there. And then I can just I'm going to trim that now. Trim the wrong line there. There we go. And trim that line up a little bit. That's odd. I don't know why it's not popping up there. Maybe I've done something a little bit off there. So, I mean, that's not a big deal. We can just change the length of this line to match that. So, we'll just... No, we don't want to extend that line. Let's just modify the value here. That'll be easier. So we'll just copy and paste that in here. There we go. Okay. So let's save that and run it. And here you go. Now you can see we got a vertical stiffener added in there. So do a plane here. Oops, didn't enter our value in there. There we go. So now you can see the vertical stiffener, and it aligns with the web of the girder there. Okay, so yeah, that's how you would do a vertical stiffener, right? Okay. So I think that's going to be about it for me on this. We didn't talk about a couple things, how to do like different planes, like local members. These are really good for vertical stiffeners on wide flanges and things like that, where you want to put it in a local member YZ plane, and then put the vertical stiffener in for the beam. So that's a good way to add those. Let's see. You can use it for other applications, of course. It's just a different way to define your plane. Oh, we didn't talk too much about the plate local offsets or rotation. So those are some other things that, just different ways to place the plates in space relative to your plane that you defined. And then we didn't talk too much about the hard lines, hard points. But essentially, those are, we can just add one here. See, you just put in coordinates of the point where you want. And like I said before, essentially what's going to happen is that you won't have plates crossing those boundaries. You can also do a hard edge option, which will draw a hard line between the two hard point properties. And again, like I said before, this is mainly intended for doing SCF extractions. You can use it for other applications if you're. It's mostly useful if you're wanting to look at particular locations on the elements. So here you can see member hard line. And real quick, we're going to just take a look at the joint mesh input file, so you can see what we did here. We have the joint mesh option line, which is pretty self-explanatory. We have the planes that we created. So if I click here, we can see the plane that we created, and then we have all the information on that plane properties window is essentially here, right? Then we have the plate surface definition, and then we have the arcs and lines for that plate surface definition. And these were all generated by the GUI when we did the plate surface definition. You'll note that these are P arc 2 and P line 2s. These are lines and arcs that are done relative to the local coordinate system of the plane. This is helpful because we're just defining things in terms of the plane. We're drawing things on the local coordinate system of the plane when we use the GUI. So this just makes a lot more sense. We do have the old type of lines and arcs that are just going to be a bit more difficult to work with the GUI. So I'd recommend using this system if you are interested in using the Joint Mesh GUI. If you ever get in here and edit these things, you might want to think about that. And you can look in the utilities manual for more information about what those lines are and what they do. Okay, so and just as a quick aside, we've created this thing. When you open up the SACS model file again, Oh, I have it already open, so let me close it down and open it up again. When you open it up again, it's not going to show you any of the plate surfaces, right? So all you need to do is go to the joint mesh, click the joint, select the joint mesh input file, and then let's see. There we go. It will bring up everything that you worked on before. So, all of your plane definitions, your plate surface definitions, your arcs, your lines, everything's going to be there. So you can pick up where you left off and start editing it again. Make modifications to the plate surfaces, add new ones, whatever you'd like to do. And then whenever you are done, save and rerun. Okay, so that's a basic workflow for the Joint Mesh GUI. And I think that's going to be it for me. We're going to open it up for questions for the next 10 or 15 minutes. So, we'll have that available to everyone. But if you don't stick around for that, thank you all for coming, and I will see you next time. Bye-bye.
Thanks for watching. If you found this video helpful, please give it a like and share it with others. If you want to see more like it, please consider subscribing to this and Bentley's other channels. Thank you, and see you next time.